Hello everyone. In this video, we will solve a problem in Munkres from exercise 2.4, problem 11.
This video is sponsored by Cheenta.com. Since 2010, Cheenta has trained thousands of students from all around the world in mathematical Olympiads, physics Olympiads, computer science and informatics Olympiads, ISI CMI entrances, and research projects for school and college students.
So it talks about continuity of function in each variable separately. Suppose consider a function f from x cross y to z. F is continuous in y if and only if for each y naught in y if you consider the x coordinate map, that is x is alone mapping to z, defined as h of x equals f of x cross y naught or x comma y naught is continuous. Means this is continuous in the variable y. F is continuous in variable y if and only if for every y naught this x projecting to z is continuous. Similarly, f is continuous in x if and only if for each x naught in x the map k from y to z, and that is defined as k of y equals f of x naught cross y. So for fixed x naught cross y, that value is taken as k of y value, and that is going to be continuous. This function k is defined for each x naught, and for every x naught this function is continuous. Only then you can call the function capital F is continuous in the variable x. Let us prove that if f is continuous, then f is continuous in each variable separately. That is, it is continuous in y and x. First, let us take y, suppose, and say that f is continuous. Consider the codomain z, and here is your domain x cross y. Now, since I know that the function capital F is continuous, so this was our given data, and we have to prove what? We have to prove that f is continuous in each variable separately. First, let us consider y variable, and then let's consider, suppose, the function h of x, which is defined as f of x cross y naught, and let us prove that this function h of x is continuous. So the domain in which h operates is capital X and it goes to z, right? Consider a open set in z. Let's say U is an open set in z. Let us say U is a open subset of z, and let's have U. Since we know capital F is continuous and this is our capital F map, we readily get that F inverse of U is open, because U is open in Z. F inverse of U is open. Now, supposing that there exists a point x1 cross y naught. Then supposing that x1 cross y naught lies in f inverse of u, we know that there is a basis element. There is a basis element, say w cross v, such that w is the basis for x and v is the basis for y, such that w cross v is entirely present inside f inverse of u. So this implies w cross y naught is a subset of f inverse of u. And since we know that h of x is capital F of x cross y naught, then we readily get that w is a subset of h inverse of u, right? Because we know that whichever x coordinate cross y naught belongs to f inverse of u, then that x coordinate should belong to h inverse of u. So w belongs is a subset of h inverse of u, and we also know that w is a basis element, so w is open in capital X. And this is true for any element of x cross y whose y coordinate is y naught, right? So we can readily see that our h inverse of u is some union of wi's, some arbitrary union of wi's, where wi is the basis element containing x1, x2, or whatever, whose cross y naught belongs to f inverse of u. So this must be open in x cross y. I mean, only in x. So we see that h inverse of u is open in x for any u open in z, which just says that h is continuous function. And this is this is true for any y naught value, because y naught is chosen arbitrary from y. And a similar proof can be followed for x naught, like keeping the proving that the function is continuous for the variable x. A similar proof can be followed for that, and you can prove it for the function k, that is k is continuous. So hence we get that if f is continuous, then that imply, let's say capital F, then that imply capital F is continuous in each variable separately. Now we can readily see that is the converse true or false, because that's our next thing that comes to our mind. So it turns out that the converse is not true. That is, if f is continuous in each variable, then capital F need not be continuous at all. And the counter example could be that the function considered from r cross r to r and defined as f of x cross y to be xy by x square plus y square when x cross y is not equal to 0 cross 0, and it is just 0 when x cross y is 0 cross 0. So you can consider the function f in each variable separately and prove that it is continuous. The function will look like some y naught x by y naught square plus x naught x square. This will be your function h of x. So this turns out to be continuous. And similarly, you can prove that k of y is also continuous because it's the same function. But this function, capital F, will not be continuous in R cross R. Think about it. We will discuss more problems.
Cheenta programs are designed for students who are passionate about mathematics, and they are personalized with one-on-one training, individual evaluation, and remedial sessions. The reason Cheenta students are successful over the last 10 years because they are taught by mathematicians and real Olympiads from leading universities in India, United States, and Europe. Some of our students come back to teach at Cheenta from Oxford, Cambridge, Harvard, MIT, UCLA, ISI, CMI, IITs, TIFR, and IISc. For more information, visit cheenta.com.